Hello, back again, and this time I'm going to try and do an experiment, which means the top of my head is going to keep disappearing, but we'll see how we get on. Right, now in the very best traditions of Mr. Graves Science, I haven't actually tried this out before, so it's going to be quite interesting to see how it goes. I am going to try and separate a fraction. We spoke last lesson about the fractions in crude oil. You have octane and pentane and heptane and all that kind of stuff, and how to separate out all these mixtures that are in one liquid together. Now I don't have any crude oil here, but what I do have here is I have a little bit of a bottle of wine left. Now wine and all alcoholic beverages is a mixture of flavoured water and ethanol, and ethanol is the alcohol that is in these things. And so in this wine, add a little bit here to my beaker, we have got a mixture, just topping up what I had here, of ethanol and water and some flavours. And what I want to do is to get the ethanol out of it and to leave the flavoured water behind. Now the way I'm going to do that is I am going to know that ethanol has got a boiling point of around about 80 degrees centigrade, whereas water's got a boiling point of around about 100 degrees centigrade. So if I can heat this thing up here on my little camping stove, and if I can get that to 80 degrees, then the alcohol vapor, the ethanol vapor, should go down this tube and then it's going to disappear into the room. So that's no good. So what I need to do is I need to cool it down. So I have got a tea towel here which I'm pouring water on, which is going all over the place. I'll keep doing a bit more of that in a minute. Also I need to heat this up, and I've got some nice alkane here. I've got some butane gas, which we discussed last lesson. I'm going to put that in my little camping stove, get that turned on, and the gas is on. So in my little wine container here, I've got a tube coming out. I've also got a digital thermometer which I keep in the kitchen, and that says that this is at around about 21 degrees at the moment. So I've got to heat this up on this little hot plate till it gets up to about 80 degrees, and then hopefully we should have some ethanol vapor coming off of here. And if I can manage to get this tea towel wet without flooding the living room, it should cool down as it goes through and condense back into a liquid, and with a little bit of luck I should have some pure ethanol arriving in my little beaker here. Now what I'm doing, you're not allowed to do unless you've got a license of distilling alcohol, so I will have to destroy it all before your eyes before we end this video. So let's leave that just to keep bubbling away for a little while. So checking my temperature here, we're now up at 27 degrees, so that's rising quite nicely. Now if you can take your eyes off of the experiment, and I'll try and do a bit of teaching while we're going along. So last lesson we looked at crude oil, which is full of all these fractions of hydrocarbons, and they're all of different lengths. The shortest chain hydrocarbon is methane, which is one carbon atom surrounded by 4 hydrogen atoms. And then if you had, you can go up to butane, which is 4 carbon atoms surrounded by 10 hydrogen atoms. And all of those methane, ethane, propane and butane are all gases. So that's from 1 carbon in the chain up to 4 carbons in the chain. If you get to 5 carbons in the chain, they turn into liquids. And so the shortest chain liquid that we've got is pentane. And I said in the last lesson that pentane actually will evaporate or boil away at about 36 degrees. And then you have, so hexane has got 6 carbons. Octane has got 8 carbons, nonane has got 9, and decane has got 10. Now if you have some petrol and you put that in your car, petrol will be a mixture of all of these hydrocarbon liquids. Just keep an eye on the temperature, that's gone off, let's put that back on again. And it's a mixture of those that goes into your car. Going on here, it's okay, it's still about 40 degrees, so we're all right for a second. Now, you may have heard of high octane fuels. A high octane fuel is a fuel that's got quite a lot of this one in there, which is octane, and that's the best one to put in your car to get the maximum amount out of it. But because that is quite rare compared to all the others, it's quite valuable, they tend to mix it in with other stuff as well. So all of these from C5 down to 10 carbons, those make up gasoline, which goes into cars. From C11, so 11 carbons down to about 16 carbons, You use that for kerosene, which is used for aircraft fuel. And beyond that, about 17 carbons in the chain, they tend to be solids. So we have gases up here, the shortest chains, and then liquids up down to about a chain of 16 carbons. And then beyond that, they become solids. Check in again, we're on about 45 degrees. So what we have here, all of these things, as you go down the chain, their boiling point increases. You have to get them hotter and hotter and hotter before they can turn into a gas. And we can use that to separate out all of the fractions in our fractional distillation. Just feeling I ought to put some safety specs on here. There's a lot of smoke coming off here, but that's just from the dirty old grill pan that I'm using. So we have, so bear that in mind, you have got gases which have got short chains and a low boiling point. You've got liquids which have got medium length chains and a high boiling point, and then you've got solids which have got an extraordinarily high boiling point. Checking my temperature, up to about 50 degrees, so we're all right for a second. Nothing coming out of here yet. A little bit more water on there to get that nice and soak in so that it will cool anything that goes across there. 6 minutes in, I'm hoping to get this done by about 8 minutes, so we'll see how we go. So up in the early 50s now. Now over here, this is how we do it for crude oil, is you don't just heat it up to a little bit and then capture that fraction. What you do is you heat it all up. You get all of the crude oil so hot that it all vaporizes, it's all evaporated. And then it goes into this fractioning tower. And as this hot vapor goes in here, it cools down as it rises up and rises up. And the slightly heavier fractions, they condense back into liquids before the lighter fractions up here. So it starts to go up here, and the things that condense at this point will be kerosene, because they will condense at a relatively high temperature. And then gasoline condenses after that, and then the gases like the methane and the butane and the propane, they will not condense and they will remain as gases. So this is how it works here. You vaporize everything and then you gradually cool it down as you go up the tower, and the different fractions drop out, they say. In fact, what they do is they condense. 60 degrees, we're looking for 80, remember. The really hot stuff here is about 350 degrees. So the things that were solids, they do actually become sticky, runny liquids. So you've got this hot, sticky goo coming out of here at around about 350 degrees centigrade. And when that cools down, that will turn into bitumen, which is like the black tar, amongst other things that they use on the roads. 65 degrees. So while we're waiting for this, what can we talk about? Hot, sticky goo, that's it. Now, before we discovered crude oil and before we started actively drilling down and looking for it, sometimes crude oil would just bubble up to the surface naturally through sort of cracks in rocks and things like that. And as it bubbled up to the surface and there would be a pool of it on the floor, all of this stuff, all of the valuable stuff, the liquids and the gases, they would just evaporate away over time and just leave sticky goo or tar there. And so you would have tar pits that would be found in various places. Where are we up to? 72. Things are going to happen in a minute. There was an episode of Scooby-Doo with a tar pit monster. But so that's what tar pits were. They were crude oil that had bubbled up and made a big pool, and then the lighter fractions had all evaporated because they are more volatile, so they will evaporate more easily. Just leaving the sticky goo behind. Right, we've got something going on here. 76 degrees. There's some condensation inside the flask here. This is nice and cool, keep that nice and wet there. And so I am looking at my little tube here to hopefully see some stuff start to condense. 79 degrees. Yeah, talk amongst yourselves. It's all starting to happen now. 80 degrees, and it is, yeah, it's still going up. I'm going to turn my gas down a little bit. I really hope science doesn't fail me now, but we've got some bubbling going on inside the wine that is at the bottom. Now, as it is at 84 degrees, that bubbling will not be the water in there, because water doesn't boil at that temperature, so that will be the alcohol coming off, the ethanol. Now it's going up here. I can hear some stuff bubbling through here, and hopefully, there we go, got a couple of little drips coming out at the end, and we can see that, and that smells like very strong alcohol. That is ethanol coming off of there. So let's leave that for a little while. got some of this stuff coming off here, so you can see it's a clear liquid in there. I don't know if you can see that sloshing around, but there's no colour to it, so the colour, the redness of the wine is left behind, and we have got some dripping coming off of here. Now, I guess you want me to prove that this is actually ethanol and not just water coming off of there, so what can I do with that? Oh, maybe we could set fire to it. Let's put some on this little glass plate and see what we get. So I've got that on there, I have a lighter. There we go, that's on fire, and so is my little tube as well. So blow that out, and you can see that we have got ethanol, which is burning down here. And as the drips come out, you can see they burn as they drop in there. And that, people, is how we turn wine into brandy, basically. So I shall destroy all that, as I have promised to do, so I won't be arrested. And that is how you separate liquids that have got different boiling points in there. And that's what we do with crude oil as well. Okay, thank you very much. Tune in next time.